Okay, today's video is going to be on clouds. Those of you that participated in the Teams meeting, this shouldn't be really brand new material for you, but this will be the notes that I actually want you to have in your notebook, as they will serve you in the days ahead to be able to know the difference between one type of cloud and another, and of course all the key terms that follow along. After this, we will be talking about precipitation. And then we'll start talking about more extreme forms of weather and essentially how they form. So in your notebook, the title of this page should be Cloud Notes. And we start out with essentially a definition of what a cloud is. You will need to know this term. Fortunately, you're writing it down, so you should just be able to look it up if you can't remember it perfectly. But a cloud is an area of condensed water vapor where the liquid or solid water floats on updrafts of air or falls very slowly. And remember that when something condenses, that means it goes from being a gas to a liquid, or even from going from a liquid to a solid, or from a gas to a solid. But you'll notice that a cloud is formed of liquid or solid water, so it's either drops of water or ice crystals. We'll talk more about that later, but you'll notice that it says they either float on updrafts of air. That means that the air coming up below them is kind of holding them up into the air until they either get heavy enough to fall downward, or they just blow away in the wind, or they're falling very slowly. Especially ice crystals and really small droplets of water, they'll just kind of hang there, and they are falling, but they're falling incredibly slowly. That's why sometimes when you look at clouds, you can see they're kind of moving around and everything. Well, a lot of that has to do with the updrafts, and that pieces are kind of falling at different speeds. The first thing we need to get down are key terms. And the first term up is humidity. And you've probably heard people mention this. This is the amount of water vapor present in the air. And this can have a big effect on how weather affects you. If you go outside during the summer and it's really hot and the humidity's high, it seems even hotter. Part of that is because there's so much water vapor in the air that water doesn't evaporate off of your skin very quickly, meaning if you sweat, it doesn't really help cool you down. And humidity refers to that. Humidity can be high or it can be low. Typically in a house, you want your humidity around 50% or below. Outside, it feels very comfortable when it's around 60%, and anything higher than that, especially on really warm days, and it gets really uncomfortable. All right, the next term is relative humidity, and all this is this compares the maximum amount of water vapor in the air at a particular temperature versus how much is actually there. The definition says the amount of water vapor in the air compared to the maximum amount of water vapor in the air at a particular temperature. Because as air changes temperature, it can either hold more or less water vapor. And we'll talk about that later, but warm air holds more water vapor, more moisture essentially in it, than cold air does. Remember, if air is cold, it's denser. It has less empty space in it than what warm air does. So warm air holds more water vapor because it has more empty space. And relative humidity, all it does is compares it to the maximum amount. If it can hold, say, I don't know, let's just use an arbitrary unit and say 100 units, and you only have 60, then the relative humidity is 60%. That it could hold 100, but it's only holding 60, and 60 out of 100 is 60%. So relative humidity talks about that. And both of these terms are really important when it comes to weather. You want to keep an eye on this, especially in the summer months. That if the humidity is really high and you're prone to getting overheated in hot weather, you may want to stay out of that weather as best you can. All right, next one, dew point. This is the temperature at which air with a given amount of water vapor will reach saturation. Now, you guys, hopefully, I assume you have, but I know some of you may have not, You may notice in the early mornings, especially during the summer months, and late of the evening, that you can go outside and the grass is wet. And hopefully you know that that's what's known as dew. And what happens is it hasn't rained or anything like that, but the temperature has dropped to a point to where that the water vapor in the air actually starts to kind of come out of it and cling to anything solid. And usually it's the grass. That's a little easier because concrete and asphalt, they stay hotter a little longer, and so the dew doesn't really condense on them. But all it means is that it's kind of like that the air is holding its maximum amount, so it can't hold anymore. It's like squeezing a sponge, that air comes out. Now, you don't see it falling out of the air, but it'll just start collecting on things that are cool enough for it to collect on, like the leaves on trees, the grass on the ground, things like that. And that's the dew point. That's the point at which that starts to happen. And whenever you see a forecast, a lot of times they will include that information in the forecast. And the dew point is kind of important as well. And I've noticed over the years that the dew point, when you get near the dew point, the humidity spikes very briefly, and then it will fall pretty rapidly after that because the water in the air starts to kind of come out of it. So that's the dew point. Next term is saturation. You may have noticed this word is in dew point, so we want to define what saturation is, and this is the point at which the rates of evaporation and condensation are equal. And probably going on to the next two terms will help you understand this definition, because they are condensation and evaporation. Hopefully by now you know condensation is when a gas changes to a liquid. A gas, what you do to change it to a liquid, you cool it down. You take energy out of it. And when you do that, it starts to get closer together. It condenses. Anytime anything is condensed, like years ago, there used to be companies, and there may still be, that sell condensed books, to where that the book is compressed down to what you just absolutely need to know. You guys will probably become familiar with these later on in life whenever you have to start reading books for classes and, giving out information on them. You get a condensed book or the Cliff Notes or something like that. All it means is that it's something smaller than it normally was. It's got less empty space essentially in it. Condensation. Now, evaporation, that's the process where a liquid changes to a gas due to random particle movement. It usually occurs at the surface. Now, you can heat water and cause evaporation to happen, but here we're talking about just more of a natural process where the molecules are flying around, and occasionally they will fly off. You can just take a cup of water and set it on, a table, dresser, or something like that, and just have it sitting there and never boil it, never really change the temperature of it, and the water will eventually evaporate away just from random particle movement. And so it changes from a liquid to a gas just due to, because if you remember, the particles will be moving around, bumping into each other, and occasionally some will just kind of fly off. So saturation is where these two processes are equal. That condensation and evaporation is essentially the same. There's not more evaporation than condensation, and there's not more condensation than evaporation. So that's what saturation is. All right, the next thing, here's another term. Yes, precipitation. This is any type of liquid or solid water that falls to Earth's surface. This could be rain, this could be snow, this could be sleet, hail. If it's falling from the sky and it's a type of water, whether it be solid or liquid, then it is considered to be precipitation. Now, we will have notes just on precipitation. That will probably be the next set of notes you take. But this is kind of important as we talk about clouds today. So make sure, I would recommend that you occasionally come back to these and just kind of go over these terms, because the better you know these, the less you're going to have to look up on a quiz or a test or something like that. But you will have them in your notebook. That way you can refer back to them. All right, so let's talk about clouds. How do clouds form? So the first thing we're going to look at here is that there's always water vapor present in the air. Here in West Virginia, in the climate that we live in, it's known as a temperate climate. And there's always a fair amount of water vapor in the air at about any given time. But you go out to places that are more like a desert, there's a lot less. Doesn't mean there isn't any, just means there's a lot less. And usually when it gets hot here, the humidity goes up, and it can feel hotter than places with actual temperatures that are higher just because they have less water vapor in the air. But there's always water vapor in the air. In the room that you're currently in, there may be a lot, may be very little. Some of you may have to run humidifiers in your home this time of year. Some of you may have to run dehumidifiers. And all that means is that a humidifier puts moisture into the air. Dehumidifiers take moisture out of the air. All right, the next thing. Warm air usually has more water vapor present than cold air. That you can pretty well count on this. There are very few exceptions that I can think of to this, but warm air usually, and just think of it as it has essentially more room for water vapor to be in the air, so it has more moisture in it. And then cold air, when you take that warm air and you start cooling it down, the water vapor will start to condense and come out of that air. That's what happens in the summer whenever it's been hot all day and then the sun, ducks behind the horizon and it starts cooling down. That a lot of that moisture that was in that really warm air, the air starts to cool, and because of that, it condenses and falls as dew. But warm air has more water vapor present than cold air. Hint, hint, I will be asking questions in the future, whether on quizzes or tests, that you need to understand this, that warm air has more water vapor, more moisture in it than cold air. Next one. As warm air rises, it cools and the vapor condenses into a liquid. If you remember how that heat is transferred to our good planet Earth, is that first radiation comes from the sun, travels across the vastness of space. A significant portion of it just kind of gets reflected back into space. Some of it gets absorbed by clouds, and about half of it actually makes it to the surface of the Earth where it's absorbed. And then that heated ground, water, things like that, they actually heat the air. And as that air heats, and that of course is due to conduction, remember two things touching is conduction when it comes to heat transfer. And as the warm air rises, it cools and the vapor condenses into a liquid. And this is how clouds form. So then after it rises and condenses, the liquid actually forms droplets, which are very small drops of water. We're talking that you could fit maybe 1 to 10,000 droplets in one drop of water that you kind of think of as dripping out of a faucet or out of a water dropper or things like that. So droplets are very, 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 very small. You kind of think about it kind of like if you have a spray bottle where you mist your hair down so you can get it to lay down. And, if you turn the setting to where it's really fine, those would be considered droplets of water. All right, the next thing. Now, the droplets do have to have something solid to condense on. They won't really condense in and of themselves. So they do have to have something solid to condense on. And you may say, but Mr. Williamson, I thought our atmosphere was all gas. And if you remember, if you were to flip back in your notes, or you remember me saying it, that I said there were trace amounts of solids in our atmosphere. Not a lot, but there are some there. And what, you may ask, are those solids? Well, they're particles such as dust, smoke, and salt from the ocean. So the droplets can actually condense on those. And I mean just a speck of dust. This dust can come from smoke. Like if you set something on fire, say you're barbecuing in your backyard and you have charcoal lit and there's smoke comes off of that, though you're releasing solid particles into the air. They're very small and they float up on up currents and things like that. So dust, smoke, and salt from the ocean all provide an area for these droplets to begin to condense on. Because remember, It is that the warm air rises, and as it rises, it starts to cool off. And the water vapor begins to condense into a liquid, and it condenses on this dust or smoke or salt from the ocean. Okay, next. The tiny droplets do one of two things in the next step. So what we find is there's water vapor present in the air. Let's just kind of break this down so you understand it better. There's always water vapor present in the air. That water vapor caught in the warmer air, it will begin to rise, because hopefully you understand that warm air rises, and warm air has more room for the water vapor. And then as that warm air begins to rise, it gets cooler because it gets farther away from the ground, and that vapor then kind of begins to condense together. And then it forms droplets, and those droplets start to condense on the dust, smoke, salt, things like that are kind of floating around in our atmosphere. And then that forms these tiny droplets. And then these tiny droplets do one of two things. First thing is they either fall very slowly or are pushed up by rising air below. So that's kind of how that a cloud just hangs there in the sky, that it isn't falling down toward the ground or anything like that, that they will fall very slowly, or they're just constantly being pushed up into the air by the rising air below. The other thing is they may freeze into very small ice crystals. Most of the clouds that you see, especially this time of year, they're kind of, half and half. They're, liquid droplets, or they're ice crystals, about half of each. They can be more of one than the other. Of course, if it's snowing, then it's probably more ice crystals. But these are the two things that those droplets will do after they've condensed on pieces of dust, smoke, salt from the ocean. All right, next. Once the droplets or ice crystals form in a large enough area, you have a cloud. You can look in the sky and you can see a cloud in the distance and see a very small cloud, or you may see a very large cloud. It just kind of depends on how much is in that particular area. And another form of a cloud that you guys have probably seen and been through, whether you've ever been on an airplane or not, is fog. Fog is a type of cloud. It's, tiny water droplets. I've actually been in situations where that I was going through fog, walking through it, and came out of it as though I had, been through rain. It's because the water droplets started kind of clinging onto my clothes and things like that. And a cloud is just like fog, only higher up in the sky. And on a really like in our springtime months or our fall months, you may see, especially if you live near the river, it'll get really foggy next to the river, and then as the sun comes out really well, you'll start to see that fog go up into the sky, and it may just form clouds, or it may just spread out to where you can't really see it. But once that the droplets or ice crystals form in a large enough area, that essentially is a cloud. Okay, the next thing. This can happen at all the different levels of the troposphere. Clouds don't really form in the stratosphere, so bear that in mind. I know that it's real easy to think, stratus clouds, they must form in the stratosphere. Well, they can form up near the stratosphere, but they don't really form in the stratosphere. And for our purposes in this class, we're just going to say that all of our weather and all of our clouds are contained in the troposphere. But just know that there are instances of some types of clouds being in the stratosphere. But I won't ask you a question and try to trick you as far as where clouds form. Just to go ahead and commit it to memory that clouds form in the troposphere. All right, the next thing. Different types of clouds. There are three main types of clouds, and then you can have variations and combinations of each. So we're going to talk about the three main types and then how they can vary. So the characteristics of clouds are based on how and where in the atmosphere they form. That's how that we essentially come up with the name for them. How they form and where they form decides how that they are named. Size and shape of a cloud, those are determined by the air movement that forms them, such as very puffy clouds They're formed by air that moves up and down very quickly. You'll usually see these in the warmer months because remember, if there's a lot of direct light from the sun and it's heating the ground up a lot, then you're going to have a more rapid air movement up and down, and that's going to form more puffy clouds. Next, flat, smooth clouds are formed by slowly rising air. Remember, this is how they are formed. Their size and shape are determined by air movement. Flat clouds, that's usually when air is rising slowly. You'll see more of these during the spring and fall times of the year, and even in the winter, that the air is not rising very rapidly. All right, next. The location of the clouds affects their composition, essentially what is in them, whether it's just droplets, whether it's ice crystals, whether it's a combination, that is affected by its location, essentially where that it forms in the atmosphere. Closer to the surface of the Earth, clouds are mostly liquid water droplets. Closer to the surface of the Earth, it's warmer. That's why when you go up into the mountains, there's snow when it might be 80 degrees down in the valley. That you can look up on mountaintops and see snow even though it's in the middle of summer. It's because the higher up you get, the cooler it gets, at least in the troposphere. And so the closer to the surface of the Earth that the clouds form, it should follow that they would be mostly liquid water because it's not that cold. Now, if they form very high up, then you're going to have more ice crystals present, and that's due to the lower temperatures in the troposphere. So kind of think about it this way. If I were to give you a particular type of cloud and tell you that it's very high up in the troposphere, what would you expect it to be made of? Liquid water droplets or ice crystals? Hopefully you would be able to say, well, it's really high up, so it'd probably be mostly ice crystals. And it's usually, if we get snow, usually it's either really cold and cold closer to the ground, and so the ice crystals are forming and form into snowflakes, or that the clouds are very high. If the clouds are very high, usually when we get snow from that, it's not a lot. It's the thicker, lower lying clouds that usually dump a bunch of snow on us. So the higher you go in altitude, the more ice crystals. Closer to the surface of the Earth, more liquid water. So you'll notice size and shape, that's affected by air movement. Location affects what it is, whether it's mostly liquid water or whether it's mostly ice crystals. All right, so now we need to talk about cloud names, the main types of clouds. Remember, their characteristics are based on how and where they form. This, is how, this is where. Cloud names. So the first one we're going to talk about is they're based on three things. Their altitude, that's one big thing. The way they form, and general characteristics as far as, how they look when you look at them. And I will go ahead and tell you that on any tests or anything in the future, I will not try to trick you on these. That if I give you an example of a cloud, it should be obvious if you know them and if you have the notes on them. All right, next, there are three main cloud names. Now, that doesn't mean that those are the only three because there are variations on each one. It just means that these are the ones that will usually be present in any cloud name, but there may be other things added to them. So the first one are cirrus clouds. And these cirrus clouds, when you see them, you usually see them on a relatively clear day. There will be wisps of them. They form at really high altitudes. So hopefully you would know that if they form at really high altitudes, then you could look up here and say, oh, they're at high altitudes. That means they're probably mostly ice crystals. And looky there, made of ice crystals. So cirrus clouds form at really high altitudes, and it should follow that they're made of mostly ice crystals. Doesn't mean that there isn't any water vapor or liquid water present. Just means if there is, it's not much. Next thing, they have a wispy, wispy or feathery appearance. And we'll show you a picture, and then I've just left a space. You don't actually have to write insert drawing here, I would just suggest actually doing a drawing of cirrus clouds. So they have a wispy, feathery appearance. And we're going to look at that. Let's see, let me find the right picture. There we go. That would be a cirrus cloud. You'll notice that the Latin word cirrus, or what this word comes from, literally means wisps of hair. And so they have this kind of wispy appearance. And this tail right here actually points to the direction that the wind is blowing. So if you were looking at this, remember they're very high up in the atmosphere. This is mostly ice crystals. And so they're indicating the direction of the wind in the higher altitudes. You don't have to do a super great elaborate drawing, just an example so that you can tell the difference from one to the other. If you need to, go ahead and pause the video here, but I'm going to move on to the next type of clouds. All right, so the next type we're going to talk about are cumulus clouds, and these are the ones probably when you hear the word cloud that you think of. Just because of the way that they look. So these form at mid to lower altitudes. This would be closer to the ground, all the way up to, not super high in the atmosphere, but high enough. These are the ones that if you look at a mountain and you see it kind of shrouded in clouds, it's usually these types that you'll see. Okay, they're characteristic. They can be a combination of liquid droplets and ice crystals. If they're at lower altitudes, probably not much ice crystals. If they're at higher altitudes, probably more ice crystals. Next thing, they kind of look, they're large fluffy clouds. They look like cotton balls kind of hanging there in the sky. And I will show you a picture of those. So you can put your drawing here in your notes. Of course, feel free to pause the video so you can actually do the drawing. But here are cumulus clouds. They look like this. They're usually the clouds you'll look into the sky and say, oh, that looks like a sleeping puppy, or that looks like a plate of fried chicken, or whatever the case may be. That's what you're going to be looking at, are actually cumulus clouds. And you'll notice a lot of times too, they kind of look flat on the underside, and then they're all misshapen on the sides and upper part. That's because of the up currents actually kind of flattening the side of them. You'll notice they'll kind of move around a lot when you're looking at them. And they can kind of bump into each other and all that. A lot of times they'll have some space between them. But these guys are usually, when they get together in a big way and get really tall, these are the guys that actually cause severe thunderstorms and things like that. They're the ones that if you look into the distance and they kind of have a black or maybe even an almost greenish look, then you're in for a good rainstorm unless, it's not moving your direction. Feel free to pause the video here and, complete your drawing and make sure you have that in the notes. That way you can readily identify cumulus cloud. We're going to move on. All right. So the next thing, stratus clouds. And stratus clouds, remember, it doesn't mean they're in the stratosphere, but they form in layers when air cools over a large area or the air is gently lifted. One of the two. And usually, like if you look outside, and I know yesterday there were a lot of stratus clouds. They weren't really high up in the air, but they were relatively a solid layer over the entire area. And I would say that it was due to the air being gently lifted. I don't know for sure, but they have a smooth appearance due to forming in calmer winds. You'll notice when you see those clouds, usually it's not really windy outside. Next, they produce steady rain showers, not violent rainstorms. So when you see these guys, they're usually not bringing a big lot of rain or snow or anything like that. They're just going to produce steady rain, kind of rain that's almost pleasant to have. Next thing, high stratus clouds are thinner than low stratus clouds. So the higher up you go in stratus clouds, the thinner they get. Lower stratus clouds will form thicker. And of course, insert a drawing here. They may be a little more difficult for you to draw. I'm not entirely sure. This picture was in the Nearpod yesterday if you were participating in that. You'll notice they're just kind of a flat layer, so you may want to draw something similar to that. And of course, the higher up they are, the more ice crystals there will be. The lower down, the more water droplets there will be. Go ahead and feel free to pause the video here if you want to work on this drawing, and I will move on to the next few things. All right, the last couple of things that we have here, and I'm going to go ahead and reveal all of this, are the variations on cloud names. Clouds that can produce precipitation. Remember, precipitation is rain or snow, any kind of liquid or solid water that falls from the sky. Usually clouds that produce those have the word nimbo or nimbus in their name. For example, cumulonimbus. That's a cumulus cloud that produces rain. You can have nimbostratus. You can have nimbocirrus. Whatever the case may be, it will have one of these words added to it. Clouds that form at medium altitude usually have the prefix alto, like you can have altostratus or altocumulus or whatever. So these are just kind of variations. So if I were to give you a name and say it is nimbostratus, and ask you, would you expect rain if you knew some nimbostratus clouds were coming your way, then hopefully you would say yes, because it has the word nimbo in its name, or nimbus, and you know that means something to do with precipitation of some kind. Could be that nimbostratus clouds are coming your way and it's really cold and you're probably going to get snow. So that's all that I have on clouds for today. And there will be probably a written assignment to go along with this in your discussion prompt that you're going to need to do for this class. I want you to tell me where the word cirrus comes from. I mentioned it a few minutes ago, or I guess you can look it up if you really want to. It is a particular word from an old language that essentially talks about this phrase right here. And that will be your discussion prompt, so make sure you put that in the discussion where that you find the link to this video. You're going to go back and you're going to post what I just asked you to post. That way you can get 10 points for actually having done the notes. And guys, let me stress to you, you need to keep track of your notes. Do not type these out. Handwrite them. Even if you want to handwrite them out and take a picture and store it on your computer, I'm perfectly fine with that. But I want you to handwrite them, because there's a lot of research that says that when you're writing, you're learning more than if you're just simply typing. So make sure that you do that. Make sure that you hang on to these notes. These will be your best friend on the test. I could tell on the recent test that many of you actually used your notes, and then I could tell that some of you didn't use them at all, or you had them incomplete or something. But make sure you have these notes down, and hopefully I will see you sooner rather than later.